Hi guys, my name is Samantha Kennedy and I work for the University of Florida Extension Service as a Family and Consumer Sciences agent in Wakulla County, Florida. And I'd like to spend the next few minutes talking to you about food thermometers and how to use them and why it's important to use them. So what I'm going to do is I'm going to talk about two different kinds of thermometers, and I'm just going to point out the different parts of the thermometers and then how to use them to measure the temperatures of food. What I'm going to do is I'm going to adjust the camera a little bit so that you can just see more of the thermometer and less of my face. So just hold on a second while I get this adjusted. So I'm just going to turn this down a little bit so that you guys can see this. So what I have here, there are two different kinds of what we call bimetallic stemmed thermometers. And so I've got two different types here. These holders are really just called sheaths, and as you can see, they have the little clip that you can put the thermometer inside of it, and then if you are going to be using it a lot, like you're a chef or something, then you can just put it into your pocket. So I don't usually do that because I just use mine at home, so I don't usually use it as in my pocket, but I do like to keep my thermometers in the sheath when I'm not using them because it protects the actual probe that you put into the food. It keeps it from getting scratched or dented or bent. So you can see there's two different ones here. These are both gauge thermometers, so they're not digital. So you can see on the faces of these thermometers that they have the temperatures and then the needle here that will actually measure what the temperature of the food is. So these are just different sizes. This has the little rubber thing on it so that it doesn't roll off the table. It prevents it from rolling off. This one doesn't have that, so you can see how it rolls easily. So this one has an advantage where it doesn't roll off the surface. But they both measure food temperatures the same way. So you have, again, the head or the face of the dial here. And then you can see underneath on this one, the calibration nut. So you can see right here that it's got a little nut underneath it, and it's called the calibration nut because when you're calibrating your thermometer, meaning you're testing to make sure that it's accurately measuring temperature, this is what you would turn to get the needle to point to the right temperature. Little needle here. And this one just has a calibration nut too, it's just a different shape. Then you have the stem of the thermometer. So this is just the stem. You can see it's made out of two different kinds of metal. You can't really tell the difference by looking at it, but that's why it's called bimetallic. It's made out of two different kinds of metal. So when you insert the probe into the food, it's actually taking two different readings from the two different metals and then giving us an average, which is what it measures here is the average. It's hard to see, but right here you'll see what we call the dimple. And on this one, the dimple is actually really far down to the end. The dimple on this one is right here at the very tip, whereas the dimple on this one is farther up here. And so when you're measuring the temperature of a food using this thermometer, you need to insert this thermometer up to the dimple so that you get an accurate reading. If you just have a food and the dimple's way up here and you just put the thermometer in like way down here, you probably aren't going to get an accurate temperature reading. This one with the dimple way down at the end does not need to be inserted quite as far, so this one might be a better choice if you had thinner foods, whereas this one needs to be inserted a little farther because the dimple is up higher from the end. It's about that far up. Okay, so if you were to want to take this and measure the temperature, you would have to insert it. For instance, these are food models that I'm going to show you. So this is not a real chicken breast, but you can see that a chicken breast has different thicknesses. So it's thin here and it's thicker here. And you always want to measure the temperature of a food in the thickest part. And I won't be able to insert the thermometer because it's not a real chicken breast, but just to show you, because of the dimple is so high up on this one and you want to get an accurate reading, you'll have to go in at an angle because you need to make sure that the probe is all the way in up to the dimple. And so you want to put it in at an angle so that you get in the thickest part of the food so that you get the accurate reading. So that's for a chicken breast. This is a chicken leg here. So again, you always want to insert the probe into the thickest part of the food. So you would insert it into the thickest part here, but you want to be careful that the probe does not touch any bone or gristle or cartilage, because those could give you a false reading, because they would get hotter than the actual meat, which is the part that we eat. And you want to make sure the meat is what is measuring at the right temperature. So again, you would probably need to go down at an angle, because if you tried to go through it like this, it would come out the other side, and you wouldn't be able to you won't be accurately measuring the temperature. A couple other examples here. Here's a hamburger patty. Again, it's a thin food, and you don't want to measure it this way, because it would go through the patty and out the other side. And if you try to do that in the pan and you pushed it down all the way through, you'd be measuring the heat from the pan and not necessarily the temperature of the meat. So you would have to go in through the side like this, all the way up to that dimple to get an accurate reading. Same thing goes for a steak. So if you had a steak, again, if you tried to go through it this way, it would go out the other side. So you would want to find the thickest part of the steak and insert the thermometer in sideways like this. And it's better with thin foods like this to actually hold it up with some tongs, or take it out of the pan and put it on a plate and then measure the temperature, so that you don't take any risk of burning yourself. And of course, if you have hot food, you're not going to be holding it with your bare hand. You will be using tongs or some other food safe utensil that will allow you to hold the food without touching it. But just for the sake of this demonstration, if you had a thin, I'm just going to hold it in my hand. And again, if it's a thin food, you want to put it sideways like this. You can also use this to measure the temperature of liquids or things that are semi-liquid. So here again, I have a glass of milk. It's not a real glass of milk, but if you had a glass of milk that you wanted to measure the temperature of, you could just take the probe and insert it down into the milk. Of course, you'd be on the inside of the glass, but down into the milk to the dimple, and then just wait for the needle to stop. So it's called an instant read thermometer, but it's not instant. It's not going to give you the temperature just like that. So you're going to want to insert the probe and then wait for the needle to stop moving. And it may take 30 seconds or longer for the needle to completely stop moving. And once it stops moving, that's going to be the temperature reading. This is a canister for yogurt. And again, if you wanted to measure the temperature of it, you would just take your probe thermometer here, and you would just insert it into the yogurt. And just again, wait for the needle to stop moving here so that you can read what it says. So the importance of measuring your food temperature is because food safety rules state that you want to keep foods at a certain temperature in order to help reduce the risk of foodborne illnesses that are caused by bacteria and viruses. So we have something called the food temperature danger zone. What that means is we want to keep hot foods above 135 degrees Fahrenheit and cold foods below 41 degrees Fahrenheit. And the way to accurately measure those temperatures and make sure that your foods are staying in the right range of temperatures, that your cold foods are staying cold and your hot foods are staying hot, are to use a thermometer, a calibrated thermometer, to measure the temperature. So it is important, turn this back up. It is important to maintain proper temperature readings in your food. So when you're cooking your food, you're going to want to measure the temperature and make sure it's reading that accurate temperature for that type of food. So we're going to share some resources with you that will allow you to look at a chart to see what temperature a different type of food needs to be in order to be considered safe. And so you'll have that when you're doing your cooking. And always make sure, again, to measure your food temperatures with a calibrated thermometer. Calibrating your thermometer is important because you want to make sure that it's accurately measuring the temperature. So you're going to want to calibrate your thermometer at least once a week, especially if you use it a lot, which you should use it a lot when you're cooking. And also if you drop it, you need to immediately calibrate it, because dropping it can actually throw the temperature readings off. So anytime it's dropped, or if it's used very often, you want to calibrate your thermometer fairly often to make sure that it's giving you an accurate reading. And I'll make sure you hold on to this piece, because this piece protects the probe on your stem thermometer. And so you want to make sure that you're putting it in the sheath, clean both the sheath and the thermometer after use, and store it in the sheath in your drawer so that you protect the probe from getting scratched or bent. So again, we'll have more resources for you to look at in terms of what the accurate temperature readings are. And I hope that you use your food thermometer frequently when you're cooking to ensure a safe final product.